Welcome to Wildcat Science with Mrs. Haugo. This is physical science and we are talking about the electromagnetic spectrum. So what I want you to do is we're going to be taking notes just like we would be if we were in the physical classroom. And so this should be done in your notebook, just like where we were taking them before, and we're going to continue the electromagnetic spectrum notes. Okay, so we talked about on Friday, the electromagnetic spectrum is the range of frequencies of all the electromagnetic waves. We also talked about that electromagnetic waves are transverse waves, which means the medium is moving in 90 degrees compared to the direction of travel. And electromagnetic waves travel at the speed of light, which is about 200,000 miles per second. So it is very fast. Actually, nothing can travel faster. We also talked about wave-particle duality. And we know that light is weird and complicated, and light will travel in packets of energy called photons. And sometimes light acts like a wave, and sometimes light acts like a particle. And we also talked about electromagnetic waves don't have mass, and they range from very low frequency, low energy, and long wavelengths to very high frequency, high energy, and very short wavelengths. So let's take a look at the electromagnetic spectrum, the spectrum of all of the electromagnetic waves. Starting at the lowest frequency, lowest energy, and longest wavelength are the radio waves, which are used for radios for carrying sound energy and other purposes. And then with a slightly higher frequency, slightly higher energy, and a shorter wavelength are microwaves, and they are used for cell phone. So all the sound information that goes from a cell tower to your phone and from your phone to a cell tower are carried, all that information is carried on microwaves. Also, microwaves use microwaves to heat up food, actually to vibrate the water particles in food, which will then heat it up. Okay, now we're going to be starting with some new things, so please pick up your pencil or pen and write down infrared waves. So infrared waves are also known as heat waves, and so they are used for heat. You have infrared waves coming off of your body right now as we speak. Obviously you can't see them, but we know that our body is hotter than the surrounding temperature, and so infrared waves are coming off our body. Also, you can more easily feel it like around a campfire. Without touching the fire, you can feel the warmth or the infrared waves coming off of that. Remote controls will also use infrared waves. And then coming to visible light waves, which are used for seeing. So everything that you can see is the visible light wave. And light is broken up into colors. The one with the longest wavelength is red, and then orange, and then yellow, and then green, and blue, and indigo, which is a type of purple, and violet. So we can see all of these colors, and there are some animals that can see outside of the visible light spectrum, and they can actually see infrared waves. So perhaps, for example, snakes can see the heat coming off of their prey. They can sense that. And also some animals can see on the other side of visible light. They can see ultraviolet rays. A lot of insects can see that, for example. So ultraviolet rays are actually a wave, just like we've been talking about, and they come off the sun. And so the sun has infrared, visible, and ultraviolet rays that are hitting us every day. And our sun, we use sunlight to make vitamin D. And also, if you get too much, then you will get a sunburn. and also skin cancer. Ultraviolet rays have enough energy to penetrate the sun, and if you get too much of it, to mutate your DNA, so you should wear sunscreen. Black lights are ultraviolet rays. So speaking of some animals being able to see ultraviolet into the ultraviolet spectrum, some insects can, and flowers actually would look different to us if we could see into the ultraviolet spectrum. Taking a look at some of these and patterns that we don't see but are visible with ultraviolet in the ultraviolet spectrum. So some insects see this instead of what we see. Okay, getting back to the electromagnetic spectrum and going to a shorter wavelength and higher energy, higher frequency are X-rays, which again are a wave, and X-rays are used for X-rays. And they have enough energy that they can be a mutagen and can cause cancer, so we want to limit our amount of X-rays. And if you've ever gotten an X-ray, they will take a lead vest and put it over all of you that isn't getting an X-ray. And then the highest energy, highest frequency are the gamma rays. And these are used for specialized medicine. So these are used for specialized medicine and other uses, and they have enough energy that they can cause cancer. So this is the highest frequency, highest energy, shortest wavelength. Give you a minute to write that down. And again, you know you can always pause it if I go too fast. And let's take a look at a picture. So here's the electromagnetic spectrum, and we have radio waves, microwaves, infrared waves, visible light, ultraviolet, X-rays, and gamma rays. So looking at the wavelength, radio waves can be as long as 10 to the third, so 1,000 meters, which is about half a mile, or 10 to the second, which is about the length of a football field, 10 to the first, about the length of a house. And then getting into microwaves, we're getting quite a bit smaller. This would be 1 meter, which is about 3 feet, 10 to the negative 1. It's about the size of a baseball. That's about a centimeter. 10 to the negative 3 is a millimeter, so that's about a period. That's microwaves. And now once we get into infrared and all of the other ones, we're getting super, super small. So this is about the size of a cell. So microscopic, infrared, and bacteria, this is about a millionth of a millimeter. And that's the part of visible light. And if you notice, visible light is a very small part of the whole electromagnetic spectrum. And so then looking even smaller, ultraviolet, the wavelength of ultraviolet rays would be about the size of a protein or a virus. And X-rays, we're getting into 10 to the negative 9th, which is a millionth the width of your fingernail. And gamma rays would be about a billionth the width of your fingernail. So frequency, as we can see, as our wavelength gets smaller, our frequency goes up, and this is waves per second. So 10 to the 6th is 1 million waves per second, a billion microwaves, a trillion, we're getting into infrared, and you can see that the sources could be people giving off infrared waves. So we've got a billionth, a trillionth, 4 trillionth, and getting smaller than that. And then this is how much energy they give off. You can see it gets a lot higher. So let's delve a little bit more into radio waves. So please write this down. Radio waves are modified to carry sound information, like a song, from the radio station to your radio. So FM are waves that have had the frequency modified, frequency modulated waves. And so anything on the FM's radio dial would have been had the frequency of their carrier wave modified. And AM radio waves have the amplitude modified. So let's look at some pictures as to what that would mean. So this, you can see you have a carrier wave, and then it has the amplitude, or the distance from the rest to the crest and the rest to the trough, has been modified. You can see it as a constant frequency. And so a station on the AM radio would have a carrier wave, and then they would modulate the amplitude to carry the sound information. We're going to compare that to a frequency modulated. So you have a carrier wave, and then you modulate the frequency, or the waves per second, and then that carries the sound information. You can see this has a consistent amplitude, but the frequency is different. So this is a video, and I think about the electromagnetic spectrum, and I think we're going to watch that in a separate video. So just a couple of things. One, do remember to be taking notes and to keep everything organized just like we did before in your physical binder. When we return to school, we will be having a binder check. So try and keep the daily routine and the physical routine where things are kept in the same place as they were before. All right, thank you. Have a good day. Bye.